Okay. We'll see how this works. All right, so we again are in chapter 3, polynomial and rational functions, 3.1 quadratic functions and applications. We were talking about how to find the vertex of a parabola using the vertex formula, and we were left with this question here. All right, so to kind of recap, before I get back into B, I did kind of skip A, which is state whether the graph of a parabola opens upwards or downwards. What we can do is just pay attention to the leading term being the highest exponent. So, all right, so in this case, what is my highest exponent? 2x squared, right? So that would be my leading term. If it is positive, it will open upwards. If it is negative, it will open downwards. So in this situation, does this graph open upwards or downwards? Upwards, because it's a positive leading term, so it will open upwards. Okay, not a big fan. Open upwards. Here we go. Any questions on that one? Pretty straightforward. All right, so we were back at identifying the vertex without doing the completing the square. So let's see if we can recall the formula. So how do I find my x value? Opposite of b. So it should be negative b divided by 2a. That's going to be very important. Yep. So remember, this is a, b, c. So when I plug it in, my b is what? Negative 10, but when I apply the negative, it will become a positive. Very good. And then I have 2 times my a, which is 2. And like you just said, that became a positive. 2 times 2 was 4. We reduced that fraction, and we got, again, we already wrote all this yesterday. I'm just trying to recap back where we were. All right, once I found out what my x was, how did I find out what my y was? I basically just plugged it in. In this case, it's a K. I think last time it was an F. I don't remember. Yeah, doesn't really matter. It's just notation stuff. But I will replace every X with that X value that I got. So that will be 5 over 2 squared minus 10 times 5 over 2 minus 5. And then we just work it out. 5 squared we saw was what? 25 over 4. Very good. So we get 2 times 25 over 4. All right, so when I take 2 times 25 over 4, we saw that that basically became what? 25 over 2. And then 10 times 5 over 2 is just what? Right, good, yes, because yes, that would give you 50 over 2. We could reduce our fraction by making. Okay, so we can reduce this to 5, and this really just becomes 5 times 5 because 10 divided by 2 is 5. So again, you can always simplify, and we just get 25 minus 5. All right, so then after that, we just keep on going with it. 25 over 2 is basically what? 12.5. So this is really 12.5 minus 25, which would be what? 12.5 minus 25. Yes, so good. It'd be negative 12.5. Oh, okay. So 25 over 2 is 12.5 minus 25 minus 5. So 12 and a half minus 25 is. Oh, you went ahead and yes, I'm not there yet. Minus 12.25 is a negative 12.5. Minus 5, negative 17.5. Yes, you could make that negative 30 and then subtract it. That's fine too. There you go. So your coordinate here for all this work we just did would be 5 over 2, comma, negative. Yes. 35 over 2, yes. I just turn it back into a fraction. I don't know if your homework's going to want to keep it a fraction or turn it into a decimal. I think both of those should be the correct answer. All right, so that's how you can do it without the completing the square. In my opinion, I think completing the square is a lot easier in this situation, but you take it as you want. All right, any questions then on part B? Yes. I don't know what your homework wants. If you gave me the answer on the test that's 2.5 and then negative 17.5, I would completely take it. I just don't know if your homework's going to want a decimal or fraction. It should take both and say, what was it been saying, like an alternate solution or something like that? It should take it. All right, any other questions there? Okay. All right, let's see if I can change colors. What's this do? Okay. Part C, it says determine the x-intercepts. What do I do for that? Cool. Hope y'all got that. All right, I'm moving on. I'm not going to rewrite all that. So on part C, finding the x-intercept, well, again, what do we know to be true? Y equals 0. Which in this case, again, I'll take the equation and set it equal to 0. So that would just be 0 equals 2x squared minus 10x minus 5. Without having to do completing the square, this process gets a little bit harder. This time we have to factor rather than just simply solve. All right. So if you recall, a trinomial always factors into what? When I do my t-chart, can I write over here? Oh, I can. I'm not limited to space. All right. Anyway, so again, this is your A, B, C. I want to multiply to A times C and add to B, if we recall that. So multiply. Okay. Yeah, so this becomes negative 10, but add to negative 10. I don't think that's going to work. Because you start off with 1 and 10 and 2 and 5. Can't be factorable. Then we get down to what's our other option when factoring fails us? It is that long equation. Do you remember the long equation? Yes. All right, so that's the route we'll go. What is the quadratic formula? Apparently I can't write it too fast, so I have to go with the pace of the computer. All right, so when we plug it in, that would just be negative 10, which is just a what?
10.
Positive 10 plus or minus square root of negative 10 squared, remembering the square always goes on the outside of the parentheses, minus 4 times 2 times negative 5. Very good. All right, so let's work it out. So we get 10 plus or minus, what's negative 10 squared? Very good. And then 4 times 2, negative 8 times negative 5, plus 40. All divided by 4. And then what's 100 plus 140? I heard it while ago. 240. 100 plus 140 is 240. 100 plus 140, 240. You're right, because I did it in my head. Oh my gosh. My brain. Because this is just 40, and then we add it, and the answer is 140. Okay. And then from there, you then have to simplify by doing the little tree method or thinking of any perfect squares that might go into it. So what route do y'all want to go? Okay, that's a good route. Then 70 breaks into 2 and 35. And then 35 breaks down into 5 and 7. But I can't go really any further. So the only thing I have is this 2 and this 2 that can come out. So that will give me 10 plus or minus 2 square root of 35. Perfect. If I can write a 3 over 4, which can then be reduced a little bit further. They can all be reduced by 2. So that will just be 5 plus or minus the square root of 35 over 2. Mhm. X-intercept. That's the x-intercept. Right? So that's this part. Because there's 2 2s. Remember, you have to have a pair to come out to become 1. So I had 2 2s, but then the 5 and the 7 did not have a pair, so it went back to 35. Oh, how did I go? Oh, because 10, 2, and 4 all have a 2 in common, so I'm able to divide them all by 2. Yeah. But remember, to divide each number, every term has to have it in common. All right? We good there? So this process becomes a little bit longer without that vertex form. All right, then it says determine the y-intercept. This is being recorded, so it's somewhere. I'm going to erase all this. Yes, that was the x-intercept. Am I good to erase? Okay. If not, there will be a recording of this in D2L at some point today, once I figure out that next task. I don't know, I'm not big on the slowness of the lag here. I will do that at least. I'm not going to record on Tuesday. Okay, can I do this? Like, how? Okay. Small. What's that? What's the difference between what's lasso select do? On accident, yeah. How lasso? I got you. That was good. We could have started with that one. All right, blue. Y-intercept is a lot easier. What did we learn about the y-intercept from the previous question yesterday? It's just going to be the last term. So remember, the y-intercept is just going to be whatever the c is, which in this case is y equals what? -5. So there's your y-intercept. Super easy to do it that way. Because we know for y-intercepts, x equals 0. So if I plug a 0 into both of these things, they'll both go away, and I'll be left with just a -5. All right, now it says to sketch the graph, which is always our favorite. If you recall from some of the things we've done so far, start off with the vertex, which was 5/2, 30. That's right. That's probably, I'm just going to do that in decimal form, probably a lot easier. So this was 2.5, comma, -17.5. So that will just be 3 over 1, 2, 3, 4, 5. I'm going to go by twos. I'm not, okay. 2, 4, 6, 8, 10, 12, 14, 16, 18. So here's 2, here's 2.5. They're about right there. Make a dot. Make a dot. More bigger dot. Okay. Somewhere around that point, right? We'll call that again the vertex, which was negative. Nope. That was a positive. Did I tell you that this is frustrating? No, it's about the C angry. Okay. Okay, so that's what that coordinate is. Then you can actually go ahead and graph either an x-intercept or y-intercept. So if I graph the y-intercept or something like that, -5, so that was 2, 4, bless you. -5 is about right here. Okay, we'll pretend there's a point there. We know it's symmetrical. So if I went 2.5 points this way up to the -5, I can go 2.5 this way and go up to -5. So that would actually put me right at 5. So this is 2, 4, so 5 would be about right there. So then I know about right here, I should have another point. Again, this coordinate right here was 0, -5, which was the y-intercept. Again, because it's symmetrical, I should be able to go 2.5 this way, which will put at 5. And it'll give me the same coordinate of -5. Yeah, it's not our best. Well, I don't have that much room. So, something like that. Yeah, back. So a lot of when you get into statistics, you can just call that 17 and put this symbol right there. Say there's a break in the graph, and then it pushes it like forward, and you get to that point. All right. Axis of symmetry. What is that? Right. And what value is it? Good. It's going to be the x value of the vertex. So axis symmetry. Yes, x equals my h, which is the vertex. So that's going to be x equals 2.5. Make sure you put the x equals. Right? Is this a minimum or maximum? This is a minimum. And then it does ask for the value. So what is the value? Very good. So negative 35 over 2 or negative 17.5. The minimum value will be whatever the y value is of the vertex. All right, and then domain and range. What is the domain? It is the x values, yes. Good. That part never changes in a quadratic. Yes. So we're about to get into. Yes. Good. It goes from lowest to highest. So that negative 17.5 will get a parentheses or bracket. Bracket. And then all the way to what? Positive infinity that gets a parentheses. All right. So there's a recap basically of what we did yesterday with the vertex equations. You can use that or completing the square. In my opinion, I think completing the square is a lot easier, but that's just my, yeah. So maybe we'll get a chance to review that. All right, we all good? Okay. The next objective was solving application problems. So take this opportunity to go ahead and write that out. If you're still struggling with the homework, please come to the tutorials. I'll be very good. It is exactly that. And how did I determine what the vertex is? We did. And how did I calculate my x? Very good. We could probably get away with it completing the square. Do you want to see that again? Yeah. You could do it both ways. If you want to continue this route, you would figure out what this is, back substitute it in to figure out what your y value is. This is what you want. I honestly don't know. I almost think maybe the formula might have been easier on this one because of the big numbers, but I really don't know. Both of them work in both scenarios. All right, so if we do this by the completing the square, which is a good practice from yesterday. What was the first thing I had to do? I have to get rid of the 80. I have to get it to a 1. So I'm going to divide everything by negative 80. So this now becomes f of p divided by negative 80. Gives me p squared minus 8 goes into 34 4 times with the remainder of 2. 8 goes into 24 3 times. Is that negative 43? Okay. And then that becomes a positive, negative 43p. And then positive 8 goes into 36 4 times the remainder of 4. 8 goes into 45 times with no remainder. 450.